we did quadratic transformations a little while ago, but who can tell me if it's plus 3, what does that mean? Good. It goes up 3. So always, if there's a constant like that, where it's a big number, it's usually up or down. So up would be plus 3 at the end, minus 3 at the end would be down 3. When it's in the parentheses, though, which way is it moving? Left and right, right? So plus 3 is actually the opposite, and everyone is in parentheses, so this would be right, left 3. What about this one down here? If this was plus 3, it was left 3, what is this one going to do?
Right.
Good. And also this little negative right here, does anyone remember what does the negative do with the parabola? It flips it, right? So negative also means it reflects over the x-axis. Let's write that down. Reflects over x-axis. And then the last one, or sorry, there's 2 more. So that 1/2, does anyone remember what, if there's a number in front, that A, what does that mean? Good. So it would be compression of 1/2. What does the minus 3 mean? Good. Right 3. And this? That plus 3 at the end? Good. And the last one, the only thing that's changing is that 3 in front. So what is that 3? Just like that 1/2 was. Compress and stretch. So it would be a stretch. Cool. So we're literally doing just that today, but we're doing it with linear, exponential, and quadratic. So y'all already learned all 3. We're just kind of basically reviewing that. So we're going to start with linear. So go to that packet for today. If you look right here, you can see that they give you, at least for quadratic, you can see they give you vertex form. Vertex form, they even tell you, hey, minus H. H stands for horizontal. So like if the opposite of whatever this is your horizontal shift, plus K is moving up and down. So they do give you that equation on your formula sheet. So we're going to start with linear. Linear, the only thing I need you focusing on is like the plus B. It is your y-intercept, but it's also like you're shifting up and down. So that B is the shift up and down. I don't need you worrying about really anything else. So for that, for linear, it's just going to be shifting up and down. So if it was minus, shifting down, if it's plus, shifting up. So what would this one be? I only want you paying attention to the constant. What would this shift be? Good. Shift down 8. What about this one? Good. Down 7. This one? Down how many? Good. This one? Beautiful. And then they want us to write this. I don't want you worrying about this, but reflect over the x-axis we know is always negative, but you're not going to be dealing with that in linear equations. So reflect over the x-axis we know is negative. A vertical compression of 1/4. We don't really see that in linear, though. It's basically just your slope. But if it's down 6, what do I put at the end? Yeah, minus 6. And then vertical stretch of 3, you can just write 3x as your slope. And if it's up 3, what do we put at the end? Okay. Easy enough, right? Any questions about linear? Linear, you're just dealing with up and down. The slope is not, it's a shift, but nothing you really have to worry about. All right, cool. Next one. exponential. We haven't done exponential in a little while. So remember the little exponent, the x and the exponent, right here? That is your horizontal shift. That's why it says h minus h, so it's your horizontal shift, which is left and right. So if it's minus h, which way is that going? Good. Right? Plus h. Good. So it's the same as the quadratic that we just did. It's just now in the exponent. And then plus k is exactly the same as the linear ones. So k is your vertical shift. So plus k is going what direction? Yeah, and minus k. So same as linear. So always, if it's at the end, it's always your vertical shift. The other ones are negative and positive. So negative, we know it means reflects over the x-axis. It means it flips. The A is your what? Same as your quadratic. What do we do when there was like a number in one of our quadratic ones? Yeah, stretch and compress. So I'll do one with you, and then I want you guys trying it on your own, and we'll go over it. So first I see, there's a 2. What does that 2 mean? Good, stretch of 2. That 4 is just my base. I don't need to do anything about that. What about the plus 3 at the end? Good, up 3. So if it was in the exponent, it'd be going left and right, but since it's the big constant, it's moving up 3. Cool. All right, so I want you guys trying the next 5 on your own, and I'm going to cold call you to go over it. So you're just writing the shifts here. For the last 2, you're writing the new equation. So it's basically like the same thing we did. Damon, did you get the first one? No. Michael, did you get the first one? Yep, reflects over x-axis, so that's the first one. That negative. Cool. And what does the 3 mean? Actually, sorry. What does the 2 mean? Perfect. Shifts left 2. Cool. Kirsten, you get number 9? What's the 8 stand for? Good. Stretch of 8. And then what is that minus 4? See, did we get this one? So negative reflects over x-axis. Right side. Keandra, want to help me write this equation? So it says it has a horizontal shift right 4. So it's telling me it has a base of 4. So I'm going to start with that base of 4. How would I write right 4? So up here I would write x minus 4. You're going to shift right 4. Where would vertical stretch be? Yep, right here. The vertical stretch is 6. And then reflects over x-axis. What does that mean? Where do I put that negative sign? Numbers and negatives. Right here. Perfect. All right, and last one, Victor, you're going to help me out. How do I write this last one? So I have a base of 3, so I'm going to start with that. And it says a vertical compression of 1/2. Where does that go? Yep. Vertical compression of 1/2 and left 2. Where is it? Yep, right here. X plus 2. Perfect. This is nothing new, right? Just kind of a review. Y'all got it? Cool, last one. We already kind of went over it. It's quadratic. So you know that the negative is reflects over x-axis. X-axis. Right is stretch and compress. What does this minus h mean? What does the h mean? Which directions? Left and right, right? So horizontal is my h, and you're given this equation. This is for x4. So minus h is to the right, plus h is to the left, and then what's the k? Yep, plus k is up, minus k is down. Beautiful. So we already did this other ticket in the door. I'm going to give you a few minutes to try to do these 6 different questions. So here you're just writing each transformation. The bottom ones you're writing the equation. So I'll give you a few minutes to try that out. All right, cool. Let's go over this. Tyreek, what's the first one? What transformations are there? What does the negative mean? Reflects over x-axis. Beautiful. What does the minus 3 mean? Beautiful. Right there. And what does the plus 7 mean? Beautiful. Everyone get that? Okay, I want to try the next one. What's my transformations? What does the 2 mean? Well, we don't know. Okay. Brandon, why don't you try this one? What's the 2 mean? Thank you. Stretches 2. What does the minus 5 mean? Beautiful. Beautiful. Keandra, what's the next one? Down 8. Perfect. Tristan, try the next one. What's the negative mean? So the negative reflects. What does the 1/2 mean? Good. Or compression. And what does the plus 3 mean? Next one, so it says I have a reflection over the x-axis, a horizontal shift of right 4, and a vertical shift down 6. So here's my x. so who can raise their hand and help me with that one? How do I write that one? Michael, give it a try. How do I do it? Where's the reflection go? What do I do for that one? Good, negative in front. And then horizontal shift of right forward. What do I put that? Good. -4 in the parentheses, and then down 5, down 6. -6. And then the last one. So we have a vertical stretch of 7 and up 8. So here's my x. There's no left and right, so I'm just going to put x squared. And if that's a stretch of 7, Tyree, where do I put that? Look at the other examples. Yeah.
Let's see. I mean,
So the +8 at the end. And then stretch of 7. Where would I put that 7? Right there. Okay. Perfect. Cool. Do we feel okay with that? Okay, so what you're going to do now is you're going to try this section. So you're writing what type of function it is, so linear, quadratic, or exponential, and then writing the transformations. So remember, if it's linear, I just want you looking at the constant. When you're finished and got those stamped off, we're going to stamp them off. What you're going to do is there is a practice quizzes you're going to do. So you're going to grab a computer and get started on that practice quizzes. So it's just practicing the transformation. So we're going to count that as a classroom. Both of these as a classroom. Sounds good. Does anyone have any questions? We're gonna go through this in a few minutes.